Today we are going to run a 14 GB weight model Gemma 426 billion parameter model on a 2 GB Mac RAM, and here is how it is. So this repo claims that you can run 2 GB RAM in your MacBook can run a 26 billion parameter model, and here is how it does. So it's actually A4B. What does A4B means? We'll discuss it later. Let's set it up first. So there is a model runs on your computer. It needs a VRAM to load all the model into its video RAM. So on Windows, you have NVIDIA graphics card, Ryzen graphics card, whatever you can do. On Apple Silicon M1 and onwards, it's called shared memory. So both GPU and CPU share the same memory, and the VRAM, the normal RAM on the MacBooks, Mac, any kind of Mac Apple Silicons is VRAM. So somehow Apple is in a good spot to do this. So that's why AI runs better on Mac. So and you don't need an extra graphics card. So this repo claims that it's native Swift and Metal Composer, and we can run it on macOS 26 plus. So let's run it. Whatever you need, you don't need anything. You just need to create a folder, open a terminal in that folder, and just paste the command. So when you paste it, it will clone the repo, it will clone the model, it will clone everything else that it needs. But I've already done it. I don't need to do it again. So let me put this aside and paste this, clear this. My this already has this. Let me show it to you. Here we have this model running, and let me show services, new terminal, and here we go. So now when I run the command, when it's downloaded and press enter, it will say destination path TurboFieldfare already exists and it's not an empty directly. So it will build it much faster. As you can see, it just opened it. So we can close this one, Control C on this one. We don't need to do it. We can download it, load it later. So by loading a model, you doesn't mean that you need to download the model. It means to load the model into the RAM so it's ready. And how does a 16 gigs of model runs on a 2 GB RAM? So what they say is that we are running an A4B model. So what does A4B means? That an active time, this is a mixture of expert model. So there are two ways model is different. It doesn't load up all the 26 billion parameters, but it imports only the expert required against that query, against that parameter, against each token. It only loads those. So it only loads 2 GB worth of memory of the model into the RAM. The rest of it stays in storage. Normally, when you run local model on Olama, MLX, or any kind of other services that we can talk about in another video, usually require you to run the whole model within a VRAM. But what they have done is they have put the rest of the model that is not required to create token into storage, and they have actually put only the required 2 GB worth of model weight into the RAM. Okay, so as you can see, I have 16 gigs of MacBook Pro M1 running, and it has 3 to 4 gigs free. And now if I click on load, it might crash, but let's give it a try. So when I click on load model, what it does is that it actually loads the model from that to our memory. So now I have 74% use. So now it's fully loaded, and how much memory it's consuming? 155 gigs. So now you can even change that, how much it can use, how much context it can support, and what else you can do. So even you can add KV cache. So what is KV cache? KV cache is a cache for the model in its own, so it doesn't do repeated work that is not required to remember context and things, so which should not take that much time, so which improves the model performance over time. For example, now we are going to run this example on it. Paris, plan a memorable first trip to Paris for a curious traveler. Give a compact 3-day itinerary with morning, afternoon, and evening ideas. Explain the easiest ways. So the whole goal is to check how good it performs, how many tokens per second we get. So as soon as I clicked on pre-fill, now it is pre-filling our model into the RAM. Whatever mixtures of experts are required from that 26 billion parameter, it will load it to the RAM, and it will take up more RAM now. So as you can see, it took up 4 gigs of RAM instantly as soon as we hit the prefill. Why does this happen? So each of those parameters it took and it loaded them. So now it's running the model, it is creating them, it is running royal roads and river views, and 26 billion parameters is a good model to run actually. So it's not that bad, but it's not even usable. So why did I suggested you to do it? The whole point of this is, oh, my Mac is hanging, so I cannot even record a video on it since it's 16 gigs M1 MacBook Pro. So that's the whole thing. So I will stop it so we can discuss why we ran this. So the whole point of running a local model for you is to learn these concepts. What does a VRAM means? How KV cache works? How a local model performs? What is a mixture of expert model? How you can load them into memory? What is the difference between different parameter models? How hallucination works? So for example, if you run a model that is around 3 billion parameters, 4 billion parameters, it will be like when you didn't know anything and when you were writing an essay in your paper and you didn't remember thing and you were spitting nothing out of like you didn't know that and you were talking about. So this is what it does. When you run a small model, it doesn't know things enough, and then it's talking and talking and doesn't know what it's doing. So to run something good, to run something better, you need a good parameter model to run it. That's the whole goal, and that's why we need bigger models. And that's the whole point of why why the GPT got successful. That's what they unlocked. Initially, everyone had this GPT model, the transformer model, the concept was there. Even Google invented it in 2017. How they came to this point that they got very successful? Their researchers found out that making a model much bigger can make it much smarter. That's the whole goal of this. And once they did it, they achieved it and they sent it. And everyone else was thought like, how can we do this? How the model is not smart enough to do things. They thought, why not? If an expert or a smaller model is doing that much hallucination and it's not performing well, what if we feed it larger amount of data? What if we feed more amount of data and train it on a much larger training data? So this is what it did and got successful. So the bigger the model data is trained on, the bigger it is. So to put it in a context, the Claude Sonnet 5 or even the Fable 5 you are running, or even the latest launched Kimi K3 is 2.8 trillion parameter model. So what does it mean? It's 2800 billion parameter model, and you are running on a 1% smarter model. So for example, if you put them both to side, you are 1% and it's a 1 to 100 comparison. So you cannot compare it to that, but it's still good enough. And in future, people will need models that run like this, specified for specific work into specific devices to run their models locally. And this is the future. Learn to run models locally, deploy them locally. This is what the future holds, and this is what every company on the world will need. See you in the next video, and my topic will be running local models, how to achieve optimization, how to run concurrent things. And in the next video, we are actually covering Mac Studio, worth of $10,000 versus $30,000 AH100 versus RTX Pro 6096 gigs of RAM, and see how good they perform. And I will be adding so many concepts in that video, and I'm working on it. I'm recording it. So please subscribe so you don't miss out on this. It will be worth it. And I've been running 14 agents. I'm in a Mac Studio, and I'm going to share my experience with you. It's been 2 months and it's really amazing, and I've learned a lot of things about that. So I'll be sharing a lot about video. So please subscribe, click the bell notification so you get notified whenever the video is launched. See you in the next video. Bye.